Have you ever seen something, thousands of individuals, moving together with this single unified purpose and wondered, who's in charge? Well, today we're diving into the pretty wild world of AI cooperative swarms. These are systems that are literally changing how we think about intelligence itself. Think about a flock of starlings, just painting these incredible patterns in the sky, or an ant colony building a city underground. There's no single leader shouting orders, right? So that begs the question, how do they do it? And it's a question that AI researchers are now answering in a way that's, it's pretty revolutionary.
For the longest time, we thought about AI in this very top-down way, One big, powerful brain giving all the commands. But swarms, they just flip that whole idea on its head. Instead of one big brain, you get many, many small, simple brains all working together. It's this huge shift from a system with central control to one with literally zero central control. And believe me, that changes everything.
Okay, so how does this collective power actually work? To really get it, we need to start with the absolute basic building blocks of any swarm.
It all starts with the agent. Think of it like a single bee in a hive. It's an individual AI, sure, but it's a total team player. The key thing here is that it makes its own decisions, but only based on the tiny little slice of the world it can see right around it.
So you've got all these individual agents. What holds them together? Well, that's the hive. But listen, the hive isn't a physical place. It's more like the core idea, the invisible network of rules and connections that lets thousands of these little guys act like one single super intelligent thing.
All right, so we have our agents and we have the hive concept connecting them. But how in the world do they coordinate without a boss? The answer is, it's surprisingly simple. It all comes down to the rules of the swarm.
This right here, this is the secret sauce. Each agent doesn't need the master plan. Nope. It just has to follow a few incredibly simple local rules. Rules based only on what's happening right next to it.
And how do they know what's going on? Through local interaction. The agents are constantly chatting, but only with their closest neighbors. It's like this constant local gossip that, when you scale it up across thousands of them, creates this huge coordinated action. It's pretty amazing.
Now, this next part is just brilliant. You know how ants leave a chemical trail for other ants to follow? Well, AI agents leave digital pheromones. They're basically digital breadcrumbs. It lets them communicate without ever talking, pointing out interesting stuff or tasks that need doing.
So let's see how this works for getting a job done. First, one agent spots something that needs to be handled. Bam! It drops a digital pheromone, kind of like raising a flag. Any nearby agents sense this and are drawn to it. Once enough of them gather, what's called a quorum, they just start the task. It's like a democratic decision, and no manager had to say a word.
Okay, this is where it gets truly mind-bending. We've seen all the simple little parts, but now we're going to see how they create something just astonishingly complex. This is the magic of emergence.
So imagine this. You program thousands of tiny drone agents, and you give them just one single local rule. Stay exactly 6 inches away from your neighbor. That's it. That's the only instruction they have.
And what happens? Look at this. It's incredible. From that one simple rule, you don't get chaos. You get a beautiful, complex, perfectly coordinated flock that moves and thinks as one. This amazing behavior was never programmed in. It just emerged from the system.
So that magic we just saw, it has a name. It's called emergence. It's the official term for when higher-level intelligence and these beautiful complex patterns just appear out of the simple, local interactions of all those individuals. It's the absolute core of all swarm intelligence.
And this one principle, emergence, it unlocks all these powerful forms of intelligence. You get swarm intelligence for solving really tough problems, the wisdom of crowds for making super accurate decisions, a kind of group mind that shares knowledge, and this incredible self-organization with zero top-down control. Now, this is all fascinating, right? But what's the point? Why do we build these things? Now we're going to connect these cool ideas to how swarms actually get things done. So while there's no leader, there is a key objective. Every single agent in that swarm is pointed towards the same mission. This shared goal creates what the source material calls a unity of purpose, and it makes sure all their little decentralized actions actually add up to something big. And this approach has some incredible advantages. Because the thinking is spread out across the whole group, there's no single point of failure. It makes the system unbelievably resilient. Their ability to self-organize means they can adapt to new situations on the fly. And by tapping into the wisdom of crowds, their collective decisions are often way more accurate than any single expert could be.
All of this adds up to something we call collective yield, which is really just a measure of the awesome output you get from the swarm. For example, a swarm might be 150% more effective than if those same agents were just working alone. It's proof that by working together this way, the group achieves way more than the sum of its parts.
So let's bring this all together. Swarm AI isn't just some new trick. It's a fundamental challenge to how we've always thought about control, about leadership, even about intelligence itself.
This quote really gets to the heart of it. The power isn't in some central command. It's in trusting the system to organize itself based on rules that are spread out across the whole group.
And this all leads to this final, really powerful idea called zero-based thinking. It's an approach that starts from a pretty radical idea. What if you don't need a leader at all? It's about designing systems from the ground up that actually thrive with little or no centralized control.
And that leaves us with a pretty fascinating question to chew on, doesn't it? We've just seen how complex, smart, and tough systems can work without a central brain. So if intelligence doesn't need a leader, what other basic assumptions we have about our world are just waiting to be completely reimagined?